Welcome. In this video, I'm going to show you how to use function notation and limit notation from the left and from the right to express the limits of both of these graphs. Well, express them if they exist. So let's begin by calling, say, this graph here of y equals g of x. And we can say this one is y equals f of x. And just assume they go on and on. Easier for me to sketch these without the arrows in the first place. In case you're wondering why they're missing, this is the x-axis and this is the y-axis. Okay, so let's look at g. As we move along the x-axis here, we're considering what happens as x approaches 3. So we're looking at the limit as x approaches 3 of g of x. So as we approach along the left side here, so that's from the negative side. You may ask, why is it from the negative side? Because there are values of x are more negative here, and they're more positive here, as in numbers get larger as we move from left to right. So we're approaching 3 from the left, from the negative side. Now, as this occurs, the outputs of this function are going down steadily. They're getting closer and closer to y equals 1. Now let's look at this from the other direction. That is, let's look at the limit as x approaches 3. This time we're going to look at this coming from the right side, so for more positive values. So the limit as x approaches 3 of g of x. And again, that's from the right-hand side, from the positive side. Well, from this direction, notice that the outputs here, as you move x along here, the outputs are staying constant. They're staying at 3. Now, you'll see more about this soon, but this number and this number, these do not match. So we cannot find the limit for this function when x equals 3. Now you'll learn more about a concept called continuity in Module 3. But visually, from the graph and what you remember from pre-calculus, this is clearly a jump discontinuity. This function is not continuous. And we'll talk more about continuity and how that relates to limits in Module 3. Let's look at this other graph here. So I'm interested in the limit as x approaches 3 from the left of f of x, and the limit as x approaches 3 from the right of f of x. Now, as we travel along the x-axis this way, you're this little person walking along here. You look up to see the outputs. The outputs are getting closer and closer to 1 as you approach from the negative side. And on the right, if you're walking along this way, heading over to x equals 3, the outputs are staying constant the whole time. And they're constant at 1 here. These two do match, so we can write the limit as x approaches 3 of f of x equals 1. And let me make that very clear. These match. And since they match, we can just write the limit without a minus or without a plus, since these match. I hope you found this video as pleasant as chuckling with a chum.